In this video, I want to introduce you to some terminology that will be useful in our discussion of functions and invertibility. And this is, in general, terminology that you'll probably see in your mathematical careers. So let's say I have a function f, and it is a mapping from the set x to the set y. And we've drawn this diagram many times, but it never hurts to draw it again. So that is my set x, or my domain. And then this is the set y over here, or the codomain. Remember, the codomain is the set that you're mapping to. You don't necessarily have to map to every element of the set or none of the elements of the set. This is just all of the elements, the set that you might map elements in your codomain to. So let's see. If I have some element there, f will map it to some element in y, in my codomain. So the first idea or term I want to introduce you to is the idea of a function being surjective. Surjective. And sometimes this is called onto. Onto. And a function is surjective or onto if for every element in your codomain, so let me write it this way. If for every let's say y that is a member of my codomain, there exists. That's the little shorthand notation for exists. There exists at least one x that's a member of x such that, and I could write such that like that. Actually, let me just write the word out. Such that f of x is equal to y. So it's essentially saying, look, you can pick any y here, and every y here is being mapped to by at least one of the x's over here. So for example, actually, let me draw a simpler example. Instead of drawing these blurbs, let's say that I have a set y that literally looks like this. Let's say that a set y, I'll draw it and let's say it has 4 elements. It has the elements a, b, c, and d. This is my set y right there. And let's say my set x looks like that. And let's say it has the elements, I don't know, 1, 2, 3, and 4. Now, in order for my function f to be surjective or onto, it means that every one of these guys have to be able to be mapped to. So what does that mean? So if every one of these guys, let me just draw some examples. Let's say that this guy maps to that. Let's say that this guy maps to that. Let's say that this guy maps to that. And let's say, let me draw a fifth one right here. Let's say that both of these guys right here map to D. So f of 4 is D and f of 5 is D. This is an example of a surjective function. So these are the mappings of f right here. This function right here is onto or surjective. Why is that? Because every element here is being mapped to. Now let me give you an example of a function that is not surjective. Let me add some more elements to y. Let's say element y has another element here called e. Now all of a sudden, this is not surjective. Not surjective. And why is that? Because there's some element in y that is not being mapped to. So if I tell you that f is a surjective function, it means that if you if you map all of these values, everything here is being mapped to by at least one element here. So you could have it, everything could be kind of a one-to-one mapping, and I'll define that a little bit better in the future. So it could just be like that and like that. And you could even have, it's at least one. So you could even have 2 things in here mapping to one thing in here. But the main requirement is that everything here does get mapped to. Another way to think about it is that if you take the image, so surjective function, let me write this here. A surjective function, or let me write it this way. So if I say that f is surjective or onto, these are equivalent terms. That means that the image The image of f. Remember, the image was all of the values that f actually maps to. So that means that the image of f is equal to y. Is equal to y. Now we learned before that your image doesn't have to equal your codomain, but if you have a surjective or an onto function, your image is going to equal your codomain. Everything in your codomain gets mapped to. And actually another word for image is range. You could also say that your range of f is equal to y. Remember, the difference, and I drew this distinction when we first talked about functions, the distinction between a codomain and a codomain is a set that you can map to. You don't have to map to everything. The range is a subset of your codomain. A range is a subset of your codomain that you actually do map to. If you were to evaluate the function at all of these points, the points that you actually map to is your range. And that's also called your image. And we use the image. The word image is used more in a linear algebra context. But if your image or your range is equal to your codomain, if everything in your codomain does get mapped to, then you're dealing with a surjective function or an onto function. Now the next term I want to introduce you to is the idea of an injective function. Injective. Injective function. And this is sometimes called a one-to-one function. So let me draw my domain and codomain again. So let's say that that is my domain, and this is my codomain. So this is x, and this is y. If I say that f is injective or one-to-one, that implies that for every value that is mapped to, so let me write it this way. For every value that is mapped to, so let's say, I'll say it a couple of different ways. There is at most one x that maps to it. There is at most one x that maps to it. Or another way to say it is that for any y that's a member of y, let me write it this way. For any y that is a member of y, there is at most one, at most, let me write most in capital, at most one x such that f of x is equal to y. There might be no x's that map to it. So for example, you could have a member of y right here that just never gets mapped to. Everyone else in y gets mapped to, but that guy never gets mapped to. So this would be a case where we don't have a surjective function. This is not onto, because this guy is not, he's a member of the codomain, but he's not a member of the image or the range. He doesn't get mapped to. But this would still be an injective function as long as every x gets mapped to a unique y. Now, how can a function not be injective or one-to-one? And I think you get the idea when someone says one-to-one. Well, if two x's here get mapped to the same y, or 3 get mapped to the same y, this would mean that we're not dealing with an injective or a one-to-one function. Injective function. So that's all it means. Let me draw another example here. So if I take, let's actually go back to this example right here. When I added this e here, we said this is not surjective anymore because every one of these guys is not being mapped to. Is this an injective function? Well, no, because I have f of 5 and f of 4 both map to d. So this is what breaks its one-to-oneness or its injectiveness. This is what breaks its surjectiveness. If I wanted to make this a surjective and an injective function, I would delete that mapping and I would change f of 5 to be e. Now everything is one-to-one. I don't have the mapping from two elements of x going to the same element of y anymore, and everything in y now gets mapped to. So this is both onto and one-to-one.